Hey guys, welcome to Section 1 and Section 2 of Chapter 9 of the Geometry program. These two sections are so intimately related, I wanted to go ahead and teach them together. That way we can get practice working throughout each of these three trigonomic functions more comfortably as the week goes on. So we're going to really focus in this chapter on right triangles and the side ratios. So there's an acronym that we use in geometry to help us remember how to find both the sine, the cosine, and the tangent ratios by something called SOHCAHTOA. So that's what this is, SOHCAHTOA. So SOHCAHTOA. And that's the way that we remember which side relationships go with which trigonomic function. So the S stands for the sine. And if we are looking for the sine of x, it's the relationship of the opposite side over the hypotenuse. So we need to identify which sides those are. So in relationship to angle x, the opposite side is this guy. The hypotenuse is always opposite the 90-degree angle. And the adjacent side is the side that is touching the angle that is not the hypotenuse. Okay? So it's really important for you to first be able to identify which angle is your reference angle, and then be able to identify which side types are in relationship to that angle. So identify the opposite, the adjacent, and the hypotenuse. All right, so the sine of x is abbreviated sin x, but we never ever say that. So please, when you're using this in communication, when you're talking to your parents or anyone else, please don't ever say the sin of x. We still pronounce it the sine of x. We just write the abbreviation because as mathematicians, we don't like to write out long words. Okay, and it is the opposite over the hypotenuse. All right. The cosine is abbreviated cos, but we don't say that either. It is the cosine of x. And that, if you look in our acronym, is the relationship of the adjacent side over the hypotenuse. And then the tangent is abbreviated tan x. Now, believe it or not, you can say tan x. I don't know. I didn't make the rules. We just follow them. And those are the side ratios of the opposite over the adjacent. Okay, you're going to see how this all plays out. I know it's a lot of letters right now, but we're going to put this to practice here in just a second. So make sure you got all of this down, and then we're going to dive in. So here's an example. Remember, we're always going to be in a right triangle. So if you're not in a right triangle, these relationships do not hold. So make sure that you're always in a right triangle, and then we can begin. All right, so in this first example, I want to find the sine, the cosine, and the tangent of angle A. So we need to identify angle A and then identify our side relationships to that. So the opposite side is going to be this 4. So he's the O. 5 is the hypotenuse, always opposite the 90-degree angle. And that leaves 3 as the adjacent side. So the touching side to the angle that's not the hypotenuse. And once you're able to identify those side relationships, then we simply need our SOHCAHTOA to fill in. So the sine of A is the opposite over the hypotenuse. So the opposite of A is 4. And the hypotenuse is 5. And that's it. If you can reduce it, you want to reduce it, but of course 4/5 doesn't reduce. The cosine of A is this adjacent side to the hypotenuse. So the adjacent is 3 over 5. And again, I get that here. The cosine is the adjacent over the hypotenuse. If you want to, if it's hard for you to identify, maybe box the sine, cosine, and tangent letters in there if you're having a hard time distinguishing what they are and what you need. And then finally the tan, I'll move this down a little bit here. The tan of A is the opposite side, which is the 4, over the adjacent side, which is 3. And that's it. So for this first part of the lesson, we're going to be working strictly with the side relationships. So they're always going to be these numerical values in fractions, and they represent the side ratios of these trigonomic functions. Okay, let's look at another one. So here we have a right triangle, and we're looking in reference to angle B right here. So the first thing we need to do is identify our opposite, adjacent, and the hypotenuse. So the opposite side here is going to be the 8. The 17 is the hypotenuse, which leaves 15 as the adjacent. Okay, I guess I always think that identifying the opposite first is the easiest, but obviously in any order would do as long as you do it correctly. All right, and so then using my SOHCAHTOA again, and if I were you, I would just keep writing this acronym over and over again until you have it memorized. So just keep writing it. The sine is the opposite over the hypotenuse. And the opposite in reference to angle B is 8, and the hypotenuse is 17. So that's your answer. In terms of the cosine of B, the cosine here is the adjacent over the hypotenuse, and the adjacent is 15 over 17. And then finally, the tangent, coming here at the end, is the opposite over the adjacent. The opposite is 8, and the adjacent is 15. All right, those are the values you're looking at. All right, let's do one more where we have to reduce it, and then actually we're going to convert it to a decimal because you have a few questions on your homework tonight where they don't ask you to leave it in exact form. So the exact form, this is worth mentioning, exact answer would be in fraction form, or it might ask you to round to the nearest, I think it's 10,000, which is kind of fun. And let's just review that for a second. If you're in a decimal form, this is the tenths place, this is the hundredths place, this is the thousandths place, and the 10,000ths place here is the fourth. So if it asks you to round to the nearest 10,000ths, remember you look at that fifth digit then and round appropriately. Okay. So here we are, another right triangle, and we're looking, now they give us all of the letters, so we have to be really clear. We're looking in reference to angle Z, so we have to find that and then label our sides correctly. So in reference to Z, the opposite side here is 30. The hypotenuse is 34, always opposite the 90. And then the 16 is the adjacent. It's the touching side. That's not the hypotenuse. Okay. All right. Now you want the sine. So let's go ahead and write our SOHCAHTOA again. Remember, the sine is the opposite then over the hypotenuse. The opposite is 30 over 34. And of course, you can reduce 30 over 34. At the very least, they're both divisible by 2, which would give us 15 over 17. Now, if they wanted this answer as a decimal, just remember, grab your calculator. You could do top divided by bottom, and then we're going to round to the nearest 10,000. So if you grab your calculator, that looks like we're probably at 0.8824. Should be your answer there. All right, next up, cosine. Cosine now is the adjacent over the hypotenuse. Check out your SOHCAHTOA. The adjacent side is 16 divided by 34, right? And then we can reduce that, of course, both by 2. And then we're going to get 8 over 17 again. And then if we divide that, we would get 0.4706, it looks like. And then finally, the tangent. And the tangent is the opposite side over the adjacent. The opposite is 30. over 16. And that is going to be 15 over 8. And as a decimal, it would be 1.8750. Yes, we would include the 0 there because it asks us to round to the 10,000th. All right. So that is going to do it for this section. And if you're ready, finish up your notes, read through the examples in the book. Remember, there's 2 sections here. The first section is just the tangent. The second is the sine and the cosine. Go ahead and read through both of those and then begin your assignment.